Part 2, the trig review. So if you're trying to find answers, finding all values for x, that means you're searching x's here as an angle. So you're looking for what is the angle that will produce when you take cotangent of this angle and then times it by itself, squaring it, and then times it by 3, it equals 1. Okay, so you're looking for an angle. Here's your answers, and you want to find all answers between 0 and 2 pi. Okay, so let's go ahead and start this one. Okay, so here's the first one, sine x equals sine 2x. So we're going to rewrite this kind of using our identities. So we'll take sine 2 times an angle. It's 2 sine x cosine x equals sine x. And then since we're solving here, we can go ahead and move stuff to either side. So we're going to go ahead and subtract sine x on both sides. So now we have two terms, right? Because here's 1 and here's 2. So two terms, we both have a sine x in it, so we can factor out a sine x. And we get left with 2 cosine x minus 1 equals 0. And now we have a product because now we're multiplying. Whenever we factor something out, we're multiplying. So and the product is 0. So we can set both of these equal to 0. So where is sine 0? So we can do the left-hand method or whatever. But sine is your y value, so where's y? Your y 0, well that's at 0, angle 0, 0 degrees, or at pi, and since we're going to 0 to pi, you want to start doing radians. So get rid of that degree kind of stuff. From now on in calculus, you're doing radians. Okay, so those are my answers around, and 2 pi, but really we just need from 0 to pi because 2 pi is the same as 0, so. And then where is cosine x times 2 minus 1? Where is that? 0. Add 1 to both sides. Divide by 2. Where's cosine of x? 1/2. So there we can do the left-hand method, or we're going in reverse here. So you could do the inverse because we're after an angle, right? So what angle is going to give you 1/2? So what angle gives us 1/2 for cosine? So it's going to be a 60-degree angle, but since we want to do radians, we go ahead and do pi thirds, and then since we're going to 0 to 2 pi, so at 60 degrees or pi thirds right here, right, because it's 1/2, cosine is basically your x, so 1/2 is smaller than root 3 over 2, right? So at pi thirds, our y value is root 3 over 2. So cosine is 1/2 at pi thirds, and it's positive, so where else is cosine positive? And the fourth quadrant, so if we take 2 pi and minus pi thirds from that, or just keep on going pi thirds around. So 5 pi thirds. So those 4 are your answers from 0 to 2 pi. Okay, next one, 0 to 2 pi again. So here we can get the cotangent squared of x by itself. So divide by 3, divide by 3. So we get cotangent squared x equals 1/3. Now if I take the reciprocal of this, reciprocal of 1/3 is 3. The reciprocal of cotangent is tangent. So where is tangent equal to 3? So again, if you know your radians, it's a 3, so that means it has 1/3, so that's pi thirds, so that should be 60 degrees, or pi thirds. So we can go ahead and do that. But first, we do need to get rid of the squared, so we square root both sides. So where's tangent of x? Plus or minus, right? When we square root, we get plus or minus. So really, we have probably 4 answers here, because each positive is going to have 2 and a negative is going to have 2 more. So where's tangent root 3? That is at that is at 60 degrees, because there's 1, 3 in there. That's how I remember it for radians. So pi thirds, which is 60 degrees. And since it's plus or minus, that means in the first quadrant, second quadrant, third, fourth, all of them. So that's first quadrant, second quadrant, 2 pi thirds, 3 pi thirds, 4 pi thirds, 4 pi thirds, and 5 pi thirds. So those are all the thirds. So there's all our answers in radians. Okay, so the next part is about graphing. So graphing, on you probably have a hard time remembering what that exactly is. Tangent's going to look something like this. It always starts at negative pi halves and goes to pi halves, and the ones in between it goes negative 1, 0, and then 1. Oops, and 1. So it looks something like this. So that's what it looks like, and then it repeats itself, right? So that's normally what tangent looks like. And so normally tangent starts at negative pi halves and to positive pi halves, and its period length, the distance between that is pi. So we're going to set what we're taking the angle of and set it equal to pi. That's going to help us find our period. So really this one is actually going to be, the period is actually going to be pi halves long instead of pi long. And then where do we normally start? And we start at negative pi halves. And so now we got to find out kind of where we start. So we go ahead and take 2x and set it equal to negative pi halves. Divide by that, which is timesing by a half, so negative pi fourths. So we're going to start at negative pi fourths. So really I can just come back here and erase this and put in negative pi fourths. And then I'm going pi halves long, right? So one thing I could do, I could just add this to my start, and that will give me my last one. Or I can find my interval length. And so that's taking my period and divided by 4, which same things as timesing by a fourth. And so we get pi eighths. So really I'm counting by eighths, so I need to make sure I have a common denominator here. So negative pi fourths, we can switch to negative 2 pi eighths. Then I can just add an eighth, which is negative pi eighths. Add another one, which is at 0. Add another one, I'm at positive eighths. And add another pi eighths, I'm at 2 pi eighths. So I'm at 2 pi eighths. And or I can reduce that down to pi fourths. So I need to erase the pi halves. So my last one is pi fourths, and we can see that is, so from owing a quarter to having a quarter, difference of 50 cents, right? So that's how you graph tangent. Where it starts is normally negative pi halves. Our y values go from undefined, so y values are undefined. This is for tangent and cotangent. Well, just tangent, our y values. Cotangent, it's just moved over a little bit. So it goes undefined, negative 1, 0, and then positive 1, and back to undefined. Now, so if something's out front, that's going to change these values, or if something's after this is taken, after this part's taken, if something's added to it, then it's going to change these y values. And then our x's always start, like I said, at negative pi halves and go to pi halves. So that's how you can do tangent. Cotangent is just a little bit different. It goes from undefined to 1, undefined 1, 0, negative 1, undefined. And cotangent starts at 0, not negative pi halves. So let me write down right here. So cotangent, y values, undefined, 1, 0, negative 1, undefined. Sine y values, and sine x start of the x values is 0. So the only one that's different starting point wise for the x values is tangent, where it starts at negative pi halves. So these two have a period of pi, and all the rest have a period of 2 pi. The y values for sine goes 0, 1, 0, -1, 0. And then for cosine, y values are 1, 0, -1, 0, and 1. And those all start, sine and cosine are period length of 2 pi. So their intervals are half pi's. All right, so that's kind of it for graphing. But you take what your angle is of whatever your trig function is. Whatever's inside, you set it equal to your start. And then you go ahead and solve. And that will tell you how to find your first x value, and then you add your interval length. Your interval length is your period divided by 4. So sometimes your period will change based on what this number is as well. And then your y values, you just, whatever's being multiplied by the trig function, you multiply it by the trig values except for your undefined. Your undefined stay undefined. And then if there's something being added at the end or at the very beginning, you add it after you multiply to change your y values. And so that's it for graphing.